Okay, let's do a brief review of the derivative, and there's no better place to start really than using the definition of the derivative, the limit definition. So what we're going to try to do is take this limit definition and execute it with 1 over x minus 1, try and find that derivative. So we start off by saying the limit as h approaches 0 of 1 over, now instead of x, we need to replace it with x plus h. So this expression right here represents f of x plus h. Now we take away from that the original expression, and of course we place all of that over h. Now we're going to have to find a common denominator here, which means this would have to be multiplied by x minus 1, and this would have to be multiplied by x plus h minus 1. So it looks a little ugly at first, but things will kind of settle down a little bit here in a second. When I look to simplify a little bit, I get x minus 1 minus, now I'm going to distribute that negative on through here, so minus x minus h plus 1. All over, I'm going to keep this in factored form here, x minus 1, x plus h minus 1. And then, of course, all that still over h. Now, the good thing about what we see here is there's a lot of simplifying that can go on here. So this can cancel with that, right? The negative 1 and the positive 1. So all we have left here is that negative h. And if we wanted to, we can actually treat this as h over 1. So that means we have a complex fraction here, fraction divided by a fraction. So what happens is we flip and multiply, right? So let's see what that looks like. Bring that over here. The limit as h approaches 0 of simply negative h over this factored form of the denominator. And then that's times 1 over h. And that's a good thing, because what that allows me to do is reduce here. And now I can attempt to do the limit. See, had I done that before, I'd have 0 over 0, and that would still be indeterminate, and that'd be a problem. But in this case, I can actually go put 0 in for h now, apply the limit, and what we wind up with is negative 1 over x minus 1 times x minus 1, or negative 1 over x minus 1 squared. So the derivative of 1 over x minus 1 is negative 1 over x minus 1 squared. Now, it's just as important to talk about times when functions are not differentiable. So we've seen situations where they're not continuous. Now we go to the next level, talk about places where they're not differentiable. So we have to watch out for vertical tangents. We have to watch out for discontinuities. And we have to watch out for sharp turns or corners. Okay, now if we look at this question, it's asking us to look at this piecewise graph, and it's telling us it has a vertical tangent at x equals negative 3, so that's something we had just mentioned. And it's asking on this interval to find the places where it's not differentiable, but yet still continuous. So because of that, this value right here, 0, is not going to apply. It is a place where the function is not differentiable, but the way the question's phrased, we don't have to worry about it right now. So because of that, we ignore 0, and we only focus in on the vertical tangent at x equals negative 3 and the corner at x equals 2. And for that reason, the answer to this question would have to be C. Now let's look at some basic differentiation rules. So we start off with the derivative of a constant. This is not e to the x. This is like pi or 7 or 4. So since e is a constant, the derivative of a constant is simply 0. So that one's an easy one. The second problem deals with a trig function. So we have to know on its own, on a standalone basis here, the derivative of the cosine function is negative sine. So all we're doing here is executing the constant rule, the idea that the negative 2 can just kind of hang out for a little bit while we go derive cosine. So now knowing that, we just have to put negative sine there. So we're going to clean that up a little bit. Final derivative, 2 sine x. Okay, and finally, h of x is really just not too bad of a function, but it's got some issues with the way it's presented. So we're going to rewrite it using the powers. So h of x will equal x to the negative 3, negative third power, plus 4x to the fifth. And we want to write this as 10x to the 1/2. Now we're ready to derive it using those basic power rules that we've talked about. So in this case, the derivative of h would be -3. Then we have to take away a power, so x to the -4th. Then we're going to go plus 20x to the 4th. And then finally 5. Why? Because drop that 1/2 down. 10 times 1/2 is 5. X to the, and 1/2 minus 1 is -1/2. I think this is okay. I don't think you need to worry too much about rewriting it. You could, I mean, an alternate way to look at this, let's use a different color here, would be -3 over x to the 4th plus 20x to the 4th minus 5 over the square root of x. But I don't think we have to get too carried away. This would be perfectly fine. Okay, and lastly, let's talk a little bit about how do I write the equation of a line that is tangent to a certain curve. So we have this curve here, x plus 4 over x. We know that there's a line that runs tangent to it at a certain point. And so really what we want to formulate here is this. Y minus some y coordinate. I'm going to stay in point slope form. And we're used to the slope times x minus some x coordinate, right? But we should know that this number right here is really the derivative, right? At a certain value. In this case, it would be the derivative at x equals -4. So we have to derive. So kind of like the last problem we saw, let's rewrite this. Let's write this as x plus 4x to the -1st. So that way, when I go to find the derivative, I really am just using some basic rules here. Derivative of x, this sometimes gets some people confused. The derivative of x is simply 1, just like the derivative of 5x would be 5. So we have 1 minus, right, careful there, 4x to the -2nd, or 1 minus 4x squared. So the reason that I actually went ahead and rewrote this function, whereas here I didn't rewrite this, was because I am going to evaluate, right? I'm going to plug in a number here, and so I wanted to make it a little nicer and a little bit more user-friendly. So now what I have to do is evaluate this derivative at x equals -4. And that gives me 1 minus 4/16. So basically 1 minus 1/4. And that would give me a value of 3/4. So that number goes right in there. And the great thing about it is that's the hard part. The easy part is I already have these coordinates because they were given to me in the problem. Now, had you not been given, let's say, both the x and the y coordinate. Let's say you were just told to find the tangent line at x equals -4. Then we would actually have to go place -4 in here to make sure we get the correct y coordinate. So I hope this review of derivatives has been helpful.